Hello everybody, Chris here, and in this video I'm going to be showing you guys how to set up a 8-direction character on a top-down game for Godot. So I'm going to be using this small art pack from Axel Art at axelart.itch.io. I'll put the link in the description if you want to go grab this and follow along. Okay, so let's start by going ahead and creating a character body 2D. So I'll click Other Node on a new scene, Character Body 2D. So this will be the base physics object for our 2D character. I'm going to right click, add a child node. We'll grab a sprite 2D. I'll also need a animation player and an animation tree. Animation tree. You may also want to add in a collision shape. So the collision shape will define where the character body can collide with. For now, let's just make it a simple circle shape. And you do that in the inspector over here. Okay, so our animation tree is going to need the animation player assigned. So click Assign in the inspector and select the animation player. We also need a tree root. So let's click on tree root and do New. And we're going to do animation state machine. So now all of the warning signs on the left over in the scene hierarchy should disappear. Let's save the scene. I'll call it, let's say, player.tscn. It's a simple project, so I'll just keep it in the root. And now we need to assign the sprite sheet for the sprite 2D. So let's grab small 8-direction characters by Axel Art, put it in here. You'll see the image is going to be kind of blurry, so it's pixel. We need to change the project settings to fix that. So go to Project, Project Settings, Textures, and then we change default texture filter from linear to nearest, hit close. Okay, pixel art's fixed for the game. Now we need to define which frame of the sprite we're actually using. So this, I believe, is in the animation tab. Basically, what you got to do is count how many rows and columns there are. So we can see 1, 2, 3, 4, 5, 6, 7, 8 columns. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 rows. So that means we want, I believe, 8 for the H frames and 12 for the V frames. And now you should see only a single frame from the sprite sheet showing at once. So let's jump the frame chords, the X to 1. No. Sorry, that's the Y to 1. Okay, so now we're looking at the up view for the character. Depending on which character you want to use, you might want to jump all the way down here. So that's going to be something like 9 for the Y position. Yep, there we go. So that's the up-facing direction for that character. It might also help to just have this open in an external program so that we can kind of look at it a little bit cleaner. So in the Windows image viewer, you can kind of look at that as a reference. So this is our column 1, row 9 image, and we are going to need to use each of these to define where the character's animation is at, depending on its direction. So remember, of course, 8 directions. So this is upright, this is right. So that means we're going to need 8 animations for idle and 8 animations for walking, just to start. So you can see that, at least from an art perspective, having to set up 8 different directions is a lot of work. So if you don't really need 8 directions, it might be easier to do a 4-direction game, because you have to do that for like every character in your game. So anyway, let's create the 8 animations for idle and the 8 animations for walking. So click on the animation player. Let's go down to animation, do new, and I'll say idle left. And what we're going to need is add track, property track, and we're going to select the sprite 2D because we're going to change the properties in that, and that is going to be the H frames and the V frames, or the frame coordinates. Maybe frame coordinates just directly would be easier. So I'll do frame coordinates. So if we right click, insert a new key here, then you'll see we have 9 and 0 here. And make sure that starts at frame 0. We might want to take the snapping and set that to something like 0.1 second, and then the animation is going to have 3 frames, I think. So 0.3 and loop it. Okay, so we have the first frame here. Now we need the next one. So go down here, right click, insert a key, and we want to increment the Y to 10, right? Because if we look at the sprite sheet, the animation is going top to bottom instead of left to right. And of course, this should actually be the idle up. So we'll take this one over here. I'm actually going to take the time of the animation and make it 0.1, and we'll rename this idle up. Okay, so it was up and then top right. and then right, so it goes clockwise. Okay. So we can just duplicate this and be idle up right. Okay, and then we click here and we increment x by 1. Yep. And then we just do that 6 more times. So this is going to be idle right. We take this, we make it a 2 on the x, duplicate, idle down right. We click here, we're going to be a 3 on the x, and so on and so forth. So idle down 4, duplicate, idle down left. So duplicate it, idle down left. Okay, increment that by 1, duplicate, idle down, idle left, increment it, duplicate, idle up left, increment it. And I think that's all 8 already. So if we went to idle up, that's already the first one. Okay, so we have the 8 idle frames. We want to do that for the walk 2. So I'll go to idle up. Let's duplicate this, and I'm going to rename it to be walk up. So now we need to make the duration 0.3 seconds. I'm going to move this to be the second frame. I'm going to right click here, insert key. So let's see here. On the first one, we want it to be 9 on the Y, and on the third one, we want it to be 11 on the Y. Okay. Yeah, so if we hit play now, there's our up animation. And we just need that 7 more times. So we can duplicate it, walk up right. And now for each of these, we want to increment the x by 1, just like so. Duplicate, and we'll do walk right. Increment each of these by 1. Duplicate, walk down right. Increment, walk down. So this would be a 4 on the x. Duplicate, walk down left. And we might be able to select all of them and just increment them by 1 at once. So let's see, did that work? Yeah, but then it set them all to the same value. So we actually need the second one to be a 10 and the third one to be an 11. Okay, so that didn't really help much. Duplicate, walk left, and then we increment. And then we duplicate that, walk up left, and we increment that by 1. So now that we have all those animations created, we'll need to set up a blend space in the animation tree. But I do want to note before we continue that when you have the animations created, as long as you don't have to change the animation track out here to a specific texture on the Sprite 2D, if you have other characters in your game that use a similar setup, the exact same frame positions like this, as I've seen some good art packs use, then you can actually reuse the same animations with different characters that just have a different sprite sheet as long as the frames match up. So you might only have to do this once if you make all the other characters in your game use a similar sprite sheet setup. Just a note there as a big time saver. Okay, so now we need to go to the animation tree. We're going to look at animation tree here. We want to create a couple blend spaces. So I'm going to right click and do a blend space 2D. So let's call this the idle. And then right click, blend space 2D. This one will be walk. So an idle, we kind of have up, down, left, right, and then 4 corners. So we use that for the positioning of our blend spaces, basically. So let's do discrete here so that when we switch between the animations, it just immediately jumps between this one and this one. There's no blending at all. And we want the top 4. So let's see if we can. So let's go to the top here. Then we're going to add a new point. And then we're going to click create points. Click up here at the top, add animation. Let's see, we're doing idle, so idle up. And then I think it doesn't need to be in the top right corner exactly. It just kind of needs to be in between. Technically, I think the point here where you're pressing up and to the right is more like 0.7 on the y-axis and 0.7 on the x-axis. If you were to normalize the vector. So roughly we'll put somewhere around there for testing purposes, idle upright, and then we have over here idle right. Then we're gonna go around here to have idle down right, then down here idle down, roughly right here idle down left. Over here, idle left. And then roughly about right here, idle up left. Okay, so basically, the idea is that when you put in your X, Y input, whichever direction is closest to the point, it's going to play that animation as you're moving your character around. So these might not be the exact positions, but I think with keyboard input, this should do just fine. But we'll have to see. So let's use the select and edit points, click on each point and set the right animation. So this one is idle up, of course. This one's idle up right. I guess we already selected them. So just make sure that they're each in the right position. So down right, and then this one, of course, at the bottom should be down, down left, left, up left, and then up. So the walk is going to be the same thing, except we use the different animations. So edit walk, add in the points. We'll start up here with walk up, and then we'll have walk up right. And make sure to change the blend to discrete, of course. On the right side, we have walk right. Down here, we have walk down right. At the bottom, we have walk down. About here, we have walk down left. To the left over here, we have walk left. And then about here, we have walk up left. Okay, so that's our blend spaces. Now, how you handle the animation tree, there's a few different ways you can do it. If you like setting parameters and having automatic transitions, you can create transitions for your animations between idle and walk and idle, so they'll go back and forth depending on if you're moving, like if there's actual character input. Another alternative is that you just use the blend spaces in the animation tree, and then you set the other logic up in your node code. So if I go to the character body and I add a script, player.gd is just fine. We'll create that. And then maybe I give it a class name player if you want. What we'll do is on function physics process, we're going to get the input from the player. Now I haven't set up any input keys, so let's do that real quick. In project settings, input map, I'll put in 4 new actions for character input, not UI input. So we'll have up, down, and then left and right, of course. So to associate with those keys, I'm going to make W for up, S for down, A for left, and D for right. So standard WASD movement. Let's close that. And then on every physics process frame, I'm just going to get what the current input is from the player. So we'll say var input vector is going to be equal to input.get vector. And then we need those string names for negative x, positive x, and then negative y, positive y. So we start with left, and then we'll get right. And negative y is actually up in Godot, and then down for the other one. So that gives us our horizontal and vertical input at once. So then we can take this and we'll use it to move the character. So just as a quick mock-up, I'll just put an export var speed up here. Let's just say 50 arbitrary units. I'll make this a float, just in case you need precision, like 50.5. And we will set the character's velocity based on that speed. So let's say velocity is going to be equal to import vector times speed. We're going to move and slide the character. So that gives us our actual movement. So now if we would have run the scene, we'd be able to see our character move around the screen, or should be able to, if he was there. Okay, there on the top left. So yeah, movement is working, but the animation isn't, of course, because we have to actually tell the animation player / tree what animation it's going to be playing based on if the character's moving or not. And we also need to set on the animation tree, if we look at the parameters here, we need to set the blend position for idle and walk as we update the input vector. Okay, so let's create a new scene. I'll call this something like the level scene or world scene. I'll save this to the project, and let's add a copy of the player to this scene. So let's find the player, bring him in here. We're gonna also want like a background. So let's just make it like a sprite 2D. I'll rename this background sprite. And then before the start of the project, I brought in just kind of a quick sample overmap from the Kinney Pack 2. So if I just put this in here for the texture, then we kind of have something like a space to move around. Maybe the character needs to double size a bit. So let's go to the main scene for the player, and I'll just scale, let's say the sprite up to double. And then the collision shape I'll make big enough for the character. I kind of like to position the sprite for a top-down about where the center of where it's walking is at. And the collision shape's fine. So now back on the game world, we can see our player is a lot bigger. Probably also want to rename the character body to be player. Okay, so now like on the world scene, if we were to, well, if we were to put it back in there as a new instance, then the player title will be there. Okay, so anyway, we move our player here. I'm going to attach a camera 2D with a remote transform so that it'll follow the player around. So let's add a camera 2D. Going to add a remote transform node. And I think the remote transform needs to go under the player. And then we assign that to the camera. So as the player moves, it's going to move the remote transform because it's a child of the player. And then we assign the position of the remote transform to also be the position of the camera 2D. So let's see, let's select the world scene as the play scene. So when we start the game, it runs this. And now we can see that when we move the player, it's going to be moving that. Let's also zoom in with the camera. So we'll make it something like a 2x or 3x zoom. Hit play. Okay, that's a little better. I want the character to move faster. So let's open up the player script. And I'll just make this a speed of 200 by default. So now our player moves a lot faster. Okay, so let's set the animation parameters. So let's see. Maybe I want to take the import vector and move it out here so it can be used in other functions. So var import, and then instead of having this local variable, we assign the vector to input. We'll use it here as well. And then after we move and slide, we want to update animation parameters. Okay, so let's create that function. Update animation parameters. So if we want to update what's on the animation tree, these blend positions, which you can see as a property path, then we need a reference to the animation tree. So let's get that with an export var. At export var animation tree. So the type is animation tree, and the property is also called animation tree. Click on player. Well, you can't assign it yet because we have to put something in this function. I'll put pass. Now we can assign the animation tree to the animation tree. With the animation tree assigned here, we can go into here and set animation tree and then the path of the property. So if you want to grab that really quick, click on the animation tree, right click here, and copy the property path. Click inside of the square brackets I just created, Control V, paste it in. That also needs quotations. So quotations and then Control V, paste it in. And that is going to be equal to our input vector. We'll say for now. Yeah, okay. Equals input. And then animation tree. We'll say the walk, copy property path, quotations, put that in there. It's going to be equal to the input as well. Now, one gotcha is that if the input vector is 0, as in there's no input from the character, I actually want it to idle in the same direction that it was previously moving in. So I'm actually going to put here if input equals vector2.0, then we're going to return. So I only want to update this when there's actually character input. Otherwise, it's just going to stay as the previous values. Okay, so that should set the parameter values here so that it can select between which direction. But we also need to select which animation we're going to be playing. So on the animation tree, we need to travel between idle and walk. So how we would do that is that first we need to get access to the playback, which is actually an animation state machine playback. So it sounds really complicated, but all we really need to do is on ready. We'll say that playback equals animation tree, and this will be this property right over here in the animation tree. So parameters / playback. We can copy the property path, paste it in there, and then that's going to assign as the animation state machine playback. So the playback allows us to call travel to the name of the blend space we want to play. So on move and slide, right after that, we can say select animation, and let's come in here and make a select animation function as well. So the select animation will take, let's say, the velocity and determine whether it's going to be idle or not. So velocity instead of input, because if it slides into a wall and it can't move, I guess we still want it to play idle animation. So that makes a little more sense than the input vector. So if velocity equals vector2.0, then we're going to say that the playback needs to travel to idle. Else, playback is going to travel to walk. Now, we do also need to make sure it's playing. So if I look at the animation tree, it's active right now. So let's hit play and see if that works. Left and right works. We have up left, which is actually going to the down right, and down right is going to the up right. So I just need to go into the animation tree and flip a couple of these nodes around. So here, this is actually supposed to be walk down because up is the -1 direction. So I actually just need to swap all of the ups with the downs. So sorry about that, but it's not too hard to fix. Walk down, and then this will be walk up. Also move it to the -1 position. Over here should be walk down right. Here should be walk up right. Here should be walk up left. Here should be walk down left. Okay, let me hit play and check that. All right. Yep. Okay. So the walking directions are working, but of course the idle animations are still going to need fixing too. So let's go into animation tree, idle here, and then we want to swap these as well. So idle left is going to be, instead of idle up left, it's going to be idle down left. Over here is going to be idle down right. Up here is going to be idle down. Down here is going to be idle up. Over here is idle up right. And then here is idle up left. Okay. Now if we hit play, we can move in all 8 directions. It should pretty much be working. Yep. Now, of course, there's no map collisions here. You have to set up all kind of like collision shapes or tile set collisions and stuff like that, but that's a totally different tutorial. So that's basically how you do the up, down, left, right movement and idling. This idle up needs a little fix, I think. So let's go to animation player and check idle up. Okay, let me hit play again. Okay, yeah, it's just that down here I changed it to the walk up left for the idle, where it should be the idle up left. And then this, of course, should be walk, sorry. And this should, of course, be idle up. And then this one should be idle up right. So idle up right. Okay. And now one more time, we'll just test all the directions. And seems like we're good. So I'll put this little demo project on my Ko-Fi and Patreon pages as well, if you need to download it for reference. But of course, the art packs, I'll post links to that in the description as well, so you can go grab that off itch.io if you need. And that'll be it for this tutorial. So that's 8-direction animation in a nutshell. I've been Chris, thanks for watching, and I'll see you guys in my future video content.